Okay, theorems about roots of polynomial equations. Unit 2, day 5. It's a mouthful. Let's do this. So any polynomial with integers, coefficients, blah, 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 blah. Lots of words. That's the rational root theorem. Okay. This next one is the conjugate root theorem. And then the last one is Descartes' rule of signs. We're actually not going to go over Descartes' rule of signs. It's just basically a way to tell you how many roots there are and how many types there are of each possible, but we're not going to do that. I just want you to see these words. I want you to kind of know them, okay? We'll get more into these, though, so you'll understand what the rational root theorem is and conjugate root theorem is once we get through some examples. So first, to find all possible rational roots, it occurs in the form of this, so P over Q, where P is factors of the constant term and Q is factors of the leading coefficient. Remember, the constant term is your number, and the leading coefficient is the leading term's number that's right in front of it. Okay? So we have to find all rational roots for each of the following equations. Let's look at A. So first we have to find factors of the constant. So P is 36. So P over Q, if P is 36, the factors of that are plus or minus 1 and plus or minus 36. Because 1 and 36 go into 36. And it has to be the positive and the negative of each of those, because negative 1 is also a factor of 36. Negative 36 is also a factor of 36. Okay, so you always have to do the positive and the negative. Then we have 2 and 18, 3 and 12, 4 and 9, and then 6. So those are all the factors of P, where P was 36. Now we have to find factors of the coefficient. So the coefficient is 2, and it's the leading coefficient. The leading coefficient is 2. The factors of that are just 1 and 2. Okay? Then to find all the possible factors, I'm just going to break this up. So we have 2 terms on bottom, which means I'm going to have 2 separate division things going on. Okay? So I have to divide all of the factors of P by 1 and all the factors of P by 2, by positive and negative 2. So when we divide all of these by 1, you just end up with 1, 2, 3, 4, 6, 9, 12, 18, and 36. They all just stay the same. Okay, positive and negative just stay the same. If we look over here, we know 1 divided by 2 is 1/2, and it's still the positive or negative. We don't have that in our first list, so I'm going to mark that one down. 2 divided by 2 is 1, which we have in the first list. 3 divided by 2 is 1/2, 1.5. We don't have that in our first list, so I'm just going to leave that as 3/2 and put it there. 4 divided by 2 is 2. We have it. 6 divided by 2 is 3. We have it. 9 divided by 2 is 3.5. We don't have that, so I'm going to leave it as 9/2. 12 divided by 2 is 6. We have it. 18 divided by 2 is 9. We have it. 36 divided by 2 is 18. We have it. So these are all of our possible factors. Okay, it's kind of a lot. It's just really tedious. That's how you find the factors, though. Possible factors. Those aren't the factors. Those are possible factors. Okay? Let's look at B now and do the same thing. So factors of the constant. The constant is negative 6. So factors of that are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Not as many as before. The coefficient is 2. So that's just plus or minus 1 and plus or minus 2. You can split those up into the 2 things. We have 6 possible factors. Well, we actually have 12 because we have the positive and the negative. We have 1, 2, 3, 6, 1/2, and 3/2. Okay? Now we are going to use those to find all the roots of this equation here. Okay, because we can't factor this. This is a cubic, and we could try using factoring by grouping. It's not going to work, though. So the only way we can do this is with this rational roots theorem. So I'm just going to start by dividing these. I'm going to use synthetic division because it's the easiest. I'm going to start with 1. I always just start with positive 1 because it makes sense to me. So if we go through this synthetic division, bring down the 2, multiply 3, add those, get 3, multiply 3, negative 7 plus 3 is negative 4, negative 4 times 1 is negative 4, negative 6 times negative 4 is negative 10. That is not a factor, so 1 does not work. Now I'm going to go to negative 1. do the same exact thing. And you can double check my work, make sure it's right. That one I came out with a remainder of 0, which means that -1 is a root. So that is one of our roots. We got one of them out of the way. Okay, so now we're left with 2x squared minus x minus 6. And we're just going to factor this. So I'm going to do it by the slip and slide. I'm going to move this, or slip it over. So I get x squared minus x minus 12. That factors to x minus 4 and x plus 3. But I'm using slip and slide, so I have to divide by 2. And I'm left with x minus 2 and 2x plus 3. But those aren't the roots. Those are the factors. So to find the factors, my first factor is -1, because that was one that worked. Okay? The next one I'm going to set x plus 2, or x minus 2 equal to 0. I get x equals 2. That's another factor, or that's another root. Then I have 2x plus 3. Solve for x, so you get x equals -3/2. Those are our 3 roots. Okay? Here, this is a 3. We found all 3 roots. We're good. Remember, this number always corresponds with how many roots there are. That could be real roots or irrational roots or imaginary roots. So that just tells you how many possible roots there are. There were 3. We found all 3. We're good. Okay? So let's go to this one. A cubic polynomial has real coefficients. If 2 of the roots are x equals 4 and x equals -5, what is the other root? So a cubic means it's raised to the 3rd degree, right? So that's like x cubed plus blah, 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 something. So it's raised to the 3rd degree. This means there's 3 possible roots. X equals 4 is a real rational root. There's nothing else we can do to that one. X equals the square root of 5 is a real irrational root. Since it's irrational, there's a conjugate pair, which means x equals negative square root of 5 is the missing root. So these are the 3 roots. This was the one we were missing. Okay? So a quintic polynomial has real coefficients. If 3 of the zeros are 2i, -3 plus square root of 5, and 1, what are the other zeros? So first, those are our given roots. A quintic is a 5th degree polynomial. Okay? So we have to find 2 more roots. We have x equals -2i. There's a conjugate pair to that. It's positive 2i. And then we also have x equals -3 plus the square root of 5. Also a conjugate pair. That's x equals -3 minus the square root of 5. Those are our 5 zeros, or 5 roots. We have 1 real root, which was 1. 2 real irrational roots, so the negative square root, or -3 plus the square root of 5 and minus the square root of 5. Then we have 2 complex or imaginary roots. Alright? So find a cubic polynomial with roots -2i and 5i. So it's cubic. Again, that means we have 3 roots. We're only given 2, we have to find the other one. It's 2i. We were given -2i, so you have to have the positive in there also. So from this right here, so we have x equals -5. I need to create that, make it into a factor. I'm just going to add the 5 over. So then that's x plus 5 equals 0. That's where I got that factor, right there. Okay? So x plus 5 is one of them. And then x plus 2i and x minus 2i is the others. So you can always just change those signs and add an x in front. Now I'm just going to multiply them out. So x plus 2i and x minus 2i multiplies to be x squared plus 4. Then I'm going to multiply x squared plus 4 to x plus 5. It's x cubed plus 5x squared plus 4x plus 20. Whoops, go back. So that is our cubic polynomial right there. It's cubic, we have a 3. That arrow is supposed to go right there. So we're good. Okay? Stop. What's happening? Sorry. We're going to save these ones for class. Please remember to take the quiz, and I will see you all tomorrow.